Hello, parents and any teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy. In this video, we're going to be looking at the meaning of addition, as well as models and strategies that your second grader will be learning. Now, in the intro to addition video that I did, I talked about the meaning of addition. Things like putting together, combining, and joining, the action of addition. And that action, think about the story problems, the word problems that your child will get. It talks about, many of them talk about putting things together, combining, and joining. So when we use the symbols, a problem like 18 plus 15, you notice how I just said it, 18 plus 15, mathematically correct, nothing wrong with it. Unfortunately, the word plus rarely appears in a word problem, but words like join and put together and combine will be in that word problem. And we know that your child or children, second graders, tend to have difficulties writing an equation to match a story problem. So one way we help is we read those problems with words like combine, join, and put together. And what I mean by if I see 18 plus 15, I'm going to say 18 combined with 15, 18 joined with 15, 18 put together with 15. All of the ways that we start to link the symbols with the story problems. So some things your child may be asked to do is model it, draw a picture to go with the story. Sometimes we'll give them a picture and ask them to come up with the story to go with the picture. Sometimes your child may be given the answer and they have to come up with a story that will give that answer. Notice in each of those ways, we're trying to come at it from a different angle to make sure that there is a depth of understanding associated with that meaning. And it's a meaning for addition that will not change as they go up through the grades. Now, you see some different manipulative materials here that your second grader may use. We have base 10 materials, 100, a 10, a 1. These are solid, they can't be broken apart. Now in grade 1, we use unifix cubes. I could have a rod of 10 and I can break it in many different ways. Now you may find that early in the second grade year, they may use these to help build the understanding here so that if I wanted to remove 18 from a number, I could see that I could break it into two parts to remove the 8. I would not have to trade this in. So this is a very useful tool for building mental strategies for computation, right? And coming up with ways to what would be called decompose a 10, which you see in the subtraction videos. So you may see this early on in grade 2, but many of your children will be using base 10 materials. And notice how I have a paper version as well as the plastic version. The paper version is just centimeter grid paper. But what's nice with this is when we want your child to draw pictures, their pictures, I'd prefer they not have every square drawn in. That would take a very long time. But see, paper, I can turn it over and see the outline of the square, the outline of this oblong, the little tiny unit squares. So you may see that. You may see just counters of some type. Clear counters, I might have some that look like this. I tend to use a lot of spray painted lima beans. Just because I get 2 colors, it's easy. We use these for many things, and you may see that in your child's classroom or something like that. And then notice dominoes. Now, you may be more familiar with images that look like this, but we'll be using a 10-frame domino. All of these materials are purposely selected to help build that conceptual understanding that we talked about in the 5 strands of math proficiency, right? That conceptual understanding and procedures come from the concepts. So these are selected to help build the concept of addition, help model the story problems, and help build the strategies that we're going to talk about. Now, in this video, your second grader will be looking at bridge to 10, which is the associative property. They may be doing doubling, and depending upon the imagery we use, we're building the foundation for the distributive property. They'll be using place value, which builds the concept of combining like terms. That combining like terms we definitely need when they get to grade 4 and are adding mixed numbers, when they're doing decimal numbers. But even didn't that combine like terms remind you of algebra? When they're combining like units, like terms. So using place value is a way to do that. So you may see a variety of materials used. Typically, they are selected very purposefully to build understanding. Now, I want to look at those dominoes that I showed you. So let's start there. I'll try to clear away some of this. And if you notice my dominoes, you see they're all 10 frames. So a 10 frames, just this 5x2 image. And we put different counters in there typically and let them start to see relationships. We use them for a lot of different things. But the thing that's nice with a 10 frame, notice how here's 2 9s, but they aren't identical. This 10 frame domino, I could match 9s with 9s and not have an identical 9. But what I should see is with every 9 that I have, 1 box will be empty. With every 8 that I have, whichever versions of the 8 that I'm working with, 2 boxes will be empty. It won't matter how I turn this. It's that 8 is always 2 fewer than 10. 9 is always 1 fewer than 10. Now, in grade K, grade 1 mainly, they would be using these as matching and just getting very comfortable with imagery for the quantities. But we need it for the foundation for the associative property imagery. So if you think about one thing I want to do is become very comfortable with combinations to make 10. So if you look at what we have here, 8, what can I combine that with to make 10? Now, notice, if I use the right image, I don't have to count up to figure that out. I can look here and see I've got 2 empty boxes, so 8 and 2 must be 10. I have to combine with the 9 here. 9 and 1 must be 10. I have 5 over here. 5 and 5 must be 10. So as I'm going through, the imagery shows me what I need for the missing pieces. So this is combinations to make 10, okay? And you may see them early in grade 2 working on that to make sure that your child's comfortable with ways to make 10. That's a key idea for the what they'll be doing as they move up into double-digit numbers. Now, I want to look a bit more at that 10 frame. And in the intro, I showed you a problem. I think it was 8 plus 5 was that first problem that we looked at. And if you think about when we're using this, I had a 10 frame and I had some counters of some type. Now, do you notice, teachers, if you're watching, do you notice how I'm using single color inside the frame? And part of the reason for that is if the kids are anything like me, if some of your students are like me, when I have a mix of colors in there, I start to see all these part total relationships, where a single color is just a cleaner image to me. Now, remember, I could have 8 like this. I could have it like that. There are many ways I can show 8. But in grade 1, your child is introduced to what is called a bridge to 10 strategy. And essentially what they're doing is they're filling in the 10 frame, filling in the holes of the 10 frame to make 10. So that's partly why we were doing combinations for 10 with the dominoes, is so we can make 10. Now notice what I have here. I have 8 and 5 becomes the same as 10 and 3. Let's say I wanted to change this, and I'd like the problem to be 9 and 6. See, what's 9 and 6 the same as? 10 and 5. And it doesn't matter which of these pieces I fill in with. I can fill in with any of them. But the nice thing when I'm working with this is that I'm wanting to think about 9 and 6 is the same as 10 and 5. But what we've done here is I'm thinking of that 6 as a 5 and a 1. See, many of you might be thinking, my child knows 9 plus 6. Why are we spending any time in grade 2 doing this? And it's great if they do know 9 plus 6. Knowing the facts will be helpful to them. But I hope you'll see that if I'm thinking right now of that 6, I'm going to do it down here. 9 and 6, I'm thinking of that 6 as 1 and 5. And instead of associating this one with the 5, I'm going to associate the 1 with the 9. See, this imagery is the imagery of the associative property. I'm breaking apart. So we aren't doing these activities to replace knowing their facts. Now, some children, this is helpful for learning their facts. That visual imagery helps them remember their facts versus memorizing straight symbols. That's more challenging for them. So for some children, this is helpful for that. But if your child knows their facts, it's still important for them to know this imagery, because just knowing the fact that the answer is 15 isn't giving them the associative property. So we want both. We want them to do both. Now, once your child gets very comfortable with this bridge to 10, just to show you a couple of additional, right? If I know 9 and 6 is the same as 10 and 5, see, what's 19 and 8 the same as? 20 and 7. What's 19 and 18 the same as? 20 and 17. See, when I was young, I would have had to write this vertically, and I would have done what we called carrying, right? You would have had 8 and 9 with 17, carried the 1. Now they'll call regrouping. We think of 17 ones as 10, 1 10 and 7 ones. We rethink it, regroup it. But it would have been a lot of symbol play, and it would have been a paper and pencil task for me. Now I'm thinking of this as 20 and 17. This is now a mental arithmetic task. Same idea here. What's 29 and 18? Same as 30 and 17. So as we're going through, I'm using that associative property to continue. Now, I could do this a little differently. See, how do I move from 2-digit, which lets me use these 10 frame images, something like this, to solving a problem like 99 plus 18. Now, I'm going to use a paper version of those base 10 materials. Okay, so I've got, that's 100. Here is a 10. Let's see if I can get out 8 ones quickly here. Now, teachers, another little tip, if you notice, when I'm putting these out, I'm not putting them randomly. I'm actually organizing them still like a 10 frame organization so that the children aren't having to keep counting. Now, right here, I have 118, right? I could be counting 100 plus 18. But see, if I want them to understand 99 plus 18 or 98 plus 18, I can just cut a hole. See, it's bridging to 100. But as we're doing this, we're still using an associative property. I've got that 99 plus 18. And I can think of 18 as 1 and 7, right? I'm sorry, 1 and 17. So I can rethink this. 99, and I think of 18 as 1 and 17. And instead of that 1 associating with the 17, I can associate the 1 with the 99. I can fill in the hole. So essentially, this bridge to 10, bridge to a place, okay? It's an associative property approach to adding those numbers, which means it's going to work as they move up through the grades. If I have this kind of a problem, that's the one I started, okay? 99 plus 18, I can fill that in. See, if it works for there, it will work for 9900s plus 1800s. I don't know if you can see, but unshaded right there, there's my 9900s. I can take one of these and slide it in there. The concept works for decimal numbers just like it works for whole numbers. That's why that property works so well. So think about if I had a problem like 97 plus 39. See, I could think of the same idea here. I want to do enough of this so that the student doesn't necessarily have to work with the materials anymore, but they could draw related pictures. They are visualizing that they've got a hole in this, and they're trying to combine that with 39. So what do I need to do? Well, I need to fill this with 3. So that means I can think of that 39 as 3 plus 36. This is a mental math problem. I don't have to illustrate it like this yet in grade 2, but this is what's taking place. I'm building that foundation. And in some cases, I could show them this symbolic representation. Some of your kids, some of your children might really attune to that. They really like seeing that. So we can do some of that, but essentially, I'm thinking of 97 plus 39 as 100 put together with 36, a mental arithmetic problem that I can do. Okay? So these are associative property approaches to the computation. That's one of the strategies. So when you hear bridge to 10 or bridge to 100, or are hearing those or seeing those things within your child's work, know that that is building the foundation for the associative property. Okay. Now, if your child knows, let's stick with the base 10 blocks. See, using base 10 blocks are helpful because it helps us know the size of the units. If I know double 2 is 4, then I know double 20 is 40. And I can even go one step further and do double 200. See, when I do double 2, when I go to double 20, that 2 doesn't mean the same thing. The size of the unit changed. So it goes from 1s to 10s. And when I get down here to double 200, that 2 doesn't mean the same thing. Now, when I was in school, we spent a lot of time on alignment. When we were doing problems, we were having to line them up in particular ways, right? But once I get this understanding of place value, and we'll look a little bit more at place value a little later, see, it's the concept of combining like size units. We heard this a lot in fractions when we were doing fractions, 3rd, 4th, 5th grade, but it was called common denominators. But the reason you found common denominators is you had to combine like size unit, like terms. So foundationally, we can use what they know here at the early fact level to say, well, if 2 plus 2 is 4, 2 tens plus 2 tens is 4 tens or 40, 2 hundreds plus 2 hundreds is 400, or 4 hundreds or 400, and I can keep going up into thousands. 10,000s. Once I get the pattern of what's going on, I understand that the size of the units is getting larger. I can use this and just continue on with that. Okay, so same idea. Let's say I change it up a bit. Let's say instead of double 2, I can do 2 plus 3. Well, same thing. If I know 2 plus 3 is 5, what's 2 tens plus 3 tens? 5 tens or 50. So you may see your children doing this instead of focusing in on columns, because we need to build that idea of combining like terms. So they may be building with things. They may be drawing pictures. At first, if I'm drawing a picture of the ones, you may see children do this, and of the tens, right? Makes sense they're going to draw a long rod. And remember, I said I use the paper ones because I can flip them over and I can see just the outlines. I may draw this for the hundreds. But what we find is your children sometimes, as they get drawing, they get in a hurry. And all of these start to look the same, especially the ones in the hundreds. So what I do is I have your children draw this for the ones. And they just draw a stick for the 10. And they draw the square for the 100. It's a way for us to tell the difference between what they're doing, those different units. And it's a very efficient way, a very quick way for them to draw these. So as we continue on, I'm going to use those same types of drawings. Now, let's think about doubling. See, think about double 13. If I double 13, let's just draw the picture. I have a 10 and 3 ones and a 10 and 3 ones. How do I double 13? I double the tens, I double the ones. Now I'm going to write this a little differently. As the child moves into grade 3, they're going to start seeing this version of double 13. And one nice thing about seeing that version of double 13, see, this image lets me see, well, that's the same as double 10 put together with double 3. I don't need parentheses, that's order of operations, and we're not going to work with that in grade 2 with your child, but this is mathematically correct. But do you see double 10, double 3? This is the distributive property. Using the right model helps us get to that distributive property easier, okay? The other side you will see with doubles, in terms of turning these images or using the images to create more mental approaches to computation versus paper and pencil, is if I have double 30, I know that's 60. What's double 29? See, I would have immediately gone to paper and pencil, but can't I use this to get this? What is this going to be? Well, it's double 30 minus 2, right? Minus that 2 I'm adjusting. Now, this is also a distributive property. What's double 29? Well, it's double 30 minus that double 1. Because how did we think of 29? As 30 minus 1. See, when we're using doubles minus 2, we're playing with this. we're really building the foundation for algebraic properties. Instead of using purely arithmetic approaches to computation, like many of us learned in elementary school, we're using more algebraic approaches. So as I said, knowing their facts is great, it's helpful, but we also need them spending time with some of these images because it's the imagery for the algebraic properties that we're wanting them to do. And once I know this, I can use this for double 30 minus 2. So this must be 58. See, I can also use it for, this must be double 30 minus 1. So I could use place value, 30 plus 20, but I could also use a double strategy for doing this. So we have many options related, okay, to these. Now, let's look at that place value. Let's spend a bit more time with place value. I want to do just a couple of examples. If I do 24 plus 55, see, think about, I could write it this way. I could write it this way. I could write it this way. I should be able to put those numbers anywhere on the page and have them still be able to add them because of place value. It's combining like terms. I've got the 24 and I've got 55. Now, at first, we may ask your child to draw these because it will be helpful as we're trying to go into the properties a bit more. It also helps reinforce the idea of like size units. But as they're going through, what do we have here? I have to combine tens with tens and ones with ones. So I know I have 20 and 50 is 70, 4 and 5 is 9. Now you may see something called partial sums. And that's a use place value approach. I'm going to start out with this vertical representation of the problem. But you may see, instead of what we learned, where we just did column by column, adding up those facts like we did, you may see something like a 9. What's 4 ones and 5 ones? 9 ones. What's 20 and 50 is 70. So you're going to see essentially the place value sums written, and then we get that total. Okay, when I'm doing place value, use place value in this way, I don't have to go right to left because I'm preserving the place value. I'm writing the sum of the places, the sum of those units when I combine them. So either way, I still get 79. So this is just another way. It's called partial sums, but essentially it's a way to use place value and really reinforce the idea of combining like places. Now, what if I change the problem a little bit? And this problem required no regrouping, no need to think about it in another way. But let's see if I had this problem. Okay. Now, for 48 plus 34, see what's going to happen here. If I'm adding these, here's my 48. Here's my 34. Now, by the way, these three could be, I could have spaces in between. That would not change it from being 8. There's no rule that you have to fill in a certain order. Mathematically, no reason for that. But I want that organizing structure, so I see 8 immediately. Notice what I'm doing. If we look at partial sums, what am I combining? I'm combining the 4 tens and the 3 tens, so I get 7 tens or 70. I'm combining the 8 ones and the 4 ones, which gives me 12 ones, or another way to think of it is a 10 and 2 ones. And then I can go ahead and add what's 70 and 10 is 80, and I end up with 82. Now, some of you may have looked at that 48 and 34 and you immediately think, oh gosh, I can just think of that as 50 plus 32. Use the associative property, right? So that's the key about procedural fluency. It's flexibility. It's looking at these and saying, oh, I could use the associative property. I could bridge to that decade. Oh, I could use partial sums if I want, use place value and combine like terms. Okay, so you have many different options, and that's what we're hoping for your child, is that instead of them thinking, which way am I supposed to do this time? They say, oh, I could do it this way, or I could do it this way, or I could do it this way. Oh, I think this one's the fastest. I'm just going to do it in my head, associative property. I'm going to do partial sums. I like that one the best. Now, same thing. Let's look at this one. See immediately, do you see the associative property? You could think of this as 30 plus 57, 87. I could think of the 29 plus 58. I don't always have to go to the first add-in. I could have thought of this as 27 plus 60. Bridge the other direction, right? Here I'm associating a 1 from here with the 29. Here I'm associating 2 from here with the 58. I'm making a decade. Do you see why we spend time early on with those 10-frame dominoes of ways to make 10? Because that's what I want them picturing and thinking about when they do this computation. I could also use partial sums. And I'm going to leave it written horizontally, but I can still combine tens with tens. So 20 and 50 is 70. 9 and 8, well, that's the same as 10 and 7, that's 17. With any of these, I still get 87. So I don't have to go to this way for doing partial sums. Do you notice in these two, I worked left to right, but I don't have to. For partial sums, I could also work right to left. I could combine the ones and I could combine the tens. Either would be mathematically correct. So we have associative property, one way that we start to build mental imagery for the computation, using algebraic properties to compute, and using algebraic approaches to compute versus purely arithmetic. We saw some models that help us get to the distributive property, build that foundation. We're using place value that builds that algebraic foundation for combining like terms. If you found this video helpful, I hope that you will give it a thumbs up, click on the bells for notifications, subscribe so you can see future videos. If you have children in other grade levels, I hope that you will look at those grade level specific videos. And thanks so much for watching.